Hi dear students, a very important example problem number 1.7 we are going to discuss in this video. So first let us see the problem first. So in the given configuration we have to find out the electric field at a point A due to these charges. And also if an electron is placed at a point A, what will be the acceleration of the electron which is kept in the point A. So this is a problem. So in your question, the charge of the electron and mass of the electron will be given. Okay, you don't worry about this. So idhula diagram kuduthirukkranga. In the configuration we have two charges, Q1 vandu +1 microcoulomb and Q2 is that is also +1 microcoulomb. But என்னன்னா origin ல இருந்து ரெண்டு சார்ஜஸ்மே வந்து they are at equal distance 2 mm distanceல தான் ரெண்டு சார்ஜுமே இருக்கு. Now the question is what will be the electric field at a point A. So we know very well when we have two charges the electric field also will be 2 at a point. So இதனால ஒரு electric field கிடைக்கும், இந்த சார்ஜாலையும் ஒரு electric field கிடைக்கும். கரெக்ட்டா? அப்ப இந்த இடத்துல how to find out the electric field by superposition principle. அதை யூஸ் பண்ணி நம்ம என்ன பண்ணலாம்னா here we can find out the electric field at a point A. That we can do first. Then we can also find out the direction, that is the second thing. And also what will happen to the electron if it is placed at this point. These three things we are going to discuss in this problem. It is very important problem. Please watch carefully. Okay. And I have drawn the second diagram here. But it is a continuation. இது வரைஞ்சு A இல இதை fix பண்ணணும். But I have projected not necessary to draw the entire diagram. So what will happen at the point A ங்கிறத here we have noted. This is the origin. So இந்த இடத்துல origin இங்க இருக்கு. This point is A. Here we have two electric fields. One is due to charge Q2 which is along the positive x-axis, and this electric field due to Q1 charge is along the positive y-axis. You know very well the corresponding unit vectors along the positive x-axis I cap and positive y-axis what will be the unit vector? This will be j cap, you know very well. So let us start with, okay va. So ஏற்கனவே நமக்கு தெரியும் electric field ங்கிறது kq by r square. நம்ம வந்து we are going to find out the superposition principle. Using the superposition principle, how can I write? So the electric field at a point A is EA vector, that is equal to 1 divided by 4 pi epsilon 0. The first charge is Q1 divided by R1 A square into R1 A cap. Correct? So this is due to the first charge. And in fact this is R1 A and this is R2 B, say for example, or R2 A, right? R2 A, right? So R1A cap is the unit vector that we can represent as a j cap later. Okay, that is the second field due to Q2 is 1 divided by 4 pi epsilon 0 Q2 divided by R2A square R2A cap. Is it correct? Yes. This is the formula from the superposition principle. Is it correct? Yes. Then I can continue like this. 1 by 4 pi epsilon 0, it is very clear, 9 into 10 to the power of 9. So 9 into 10 to the power of 9. The charge is 1 microcoulomb. So you can write it as 1 into 10 to the power of minus 6 coulomb divided by distance. What is the distance? If this is 2 millimeter, this is also 2 millimeter. So 2 into 10 to the power of minus 3 the whole square. Correct? 1 millimeter is equal to 10 to the power of minus 3 meter. R1A vector is the unit vector which is along the positive y-axis. What is the unit vector? It is j cap, correct? Plus 9 into 10 power 9. Once again 1 into 10 to the power of minus 6 divided by 2 into 10 to the power of minus 3 the whole square into what is R2A? It is parallel to x-axis. Then you can represent as I cap. Is it clear? Yes. Then it is very simplified one. You can easily simplify this one, and 9 into 10 power 9 you can use this into 10 power minus 6 divided by 2 square 4 into 10 power minus 6. Is it clear? J cap plus the same thing 9 into 10 power 9 into 10 power minus 6 divided by what is that? 4 into 10 power minus 6 into I cap. So what will happen here? 10 power minus 6 is getting cancelled. Okay, va? Right. Okay, so you can get like this. So 9 by 4 is how much? 9 by 4 is 2 4s are 8, then balance 1 by 4. 1 by 4 is 0.25. So 2.25 into 10 to the power of 9 j cap plus the same thing 2.25 into 10 to the power of 9 I cap. So this is the electric field vector at this point. In vector form we have written. If you want the magnitude, then you just take the modulus. Am I right? So modulus of EA vector is equal to root over, you can write like this, 2.25 into 10 to the power of minus plus 9 only, the whole square plus 2.25 into 10 to the power of 9 the whole square. Am I right? Okay, then this will be equal to, you can write like this. Okay, one step I am, this will be 2 times, am I right? So 2 into 2.25 into 10 to the power of 9 the whole square, and this can be written as 2.25 into 10 to the power of 9 into root 2. Am I right like this? Okay, so this is the magnitude of this vector. Okay, va? So this is the magnitude of the electric field, which is 2.25 into 10 to the power of 9 into root 2. So that is the formula you can get. So you take the modulus and simply you can take root of 1 square plus root of 1 square, that is also root of 2 you will get. So this is the magnitude. What is the unit? Newton per coulomb, NC power minus 1. This is the electric field. Now let us proceed. What will be the direction of the vector? So EA vector, that is in fact EA vector is in this I plus j. Okay, so ij means in the xy plane. The electric field lies in the xy plane because we have I component as well as j component. For example, if you take this quantity 2.25 into 10 to the power of 9 outside, so you will get I cap plus j cap. So this is the electric field directions. I cap plus j cap lie in the xy plane. Is it clear? Okay, so then you take the modulus. So no need to proceed this way. This is also, it is very simple. Just you take root of 1 square plus 1 square, that will give you root 2. So I have taken from this. So nothing will happen. You can also follow this either this way or you can follow this way. So EA is equal to 2.25 into 10 to the power of 9 into root of 1 plus 1 will give you root 2, right? Now let's go to unit vector along this way. So to find the unit vector, n cap is equal to n vector divided by modulus n vector. This is the formula to calculate the unit vector. So for this the direction to find out EA cap, that can be written as EA vector divided by modulus EA vector, right? And this will be equal, what is your EA vector? It is 2.25 into 10 to the power of 9 into I cap plus j cap, right? And that is divided by modulus EA. What is modulus EA? It is nothing but 2.25 into 10 to the power of 9 root 2. Okay, so 2.25 into 10 to the power of 9 will be cancelled. Therefore the direction, the unit vector along this EA, what is the direction? Direction of the electric field is, it is clearly explained by vector, but the direction of the vector is EA cap. EA cap is the unit vector that is represented by the direction of the electric field, and which will be I cap plus j cap divided by root of 2. Am I right? So either you can represent by vector. If you represent the electric field by vector, you will get this one, or if you represent by this unit vector, then you will get I plus j divided by root 2. Then what is the next question? The next question is, if you place a electron, an electron at a point A, then what will be the acceleration? You know very well, yes, to find the acceleration, acceleration A vector is equal to force vector divided by mass. Here force is Q into E vector at a point A divided by mass, right? Okay, what is the charge of electron? It is minus 1.6 into 10 to the power of minus 19 into your electric field vector. What is your electric field vector? It is here 2.25 I plus into 10 to the power of 9 into 10 to the power of 9 into I cap plus j cap, correct? So this is what your electric field, which is divided by mass of the electron, 9.1 into 10 to the power of minus 31. Okay, so if you simplify this, you will get minus 1.6 into 2.25, which is divided by 9.1 into the powers is 40 minus 19, so 10 to the power of you will get 21 I plus j, right? So if you divide this quantity, answer is 0.395 into 10 to the power of 21 I plus j, right? If you represent in scientific form, multiply by 10 and divide by 10. If you multiply by 10, you will get a 3.95. If you divide by 10, you will get 10 to the power of 20 I plus j. So this is the acceleration of the electron, which is kept at a point A in your configuration, right? So the unit is meter per second square, right? Okay, meter per second square is the answer, or you can say Newton per kilogram, right? Because this is force, this is mass, you can write it as Newton per kilogram, or you can say Newton kilogram to the power of minus 1. Okay, so this is the acceleration of the electron, which is kept in the point A in the configuration. So what will happen to the direction? It is exactly minus of I plus j. The electric field is acting in the xy plane, it is I plus j. But here the minus of I plus j means the electron is accelerated in the exact opposite of xy plane. Okay, so this will lie in the minus x minus y, right? Minus x minus y plane. So minus of I plus j. It is normally in the third quadrant of our configuration. So first quadrant all plus, second quadrant x axis negative, y axis plus. Third quadrant both are negative, both the x axis as well as y axis negative. That's why the minus of I plus j is represented. So the acceleration will be exactly opposite to the total electric field of the system. Okay, so this is very important problem. So just to go through it and work for twice or thrice, then you can easily understand. So entirely watch the video till the end, then you will understand everything. Okay, thank you.